each of the following functions, I have 3 listed here. I want to determine whether the function is one-to-one. If it's one-to-one, give an equation or graph for its inverse. So for part A here, I have x cubed plus 1 over 2x. I created a graph of that on my graphing calculator so that I could see if it passes the horizontal line test. So the horizontal line test is what tells us if a function is one-to-one, and that does not pass because for several horizontal lines, it will hit the graph in 2 different places. And you can check that without the graph by seeing that 2 different x values can give you the same y value. Okay. So that fails the horizontal line test, so it is not one-to-one. And then g of x, the square root of x plus 9, because that's just the principal square root and not plus or minus, then I know that it's one-to-one. There aren't 2 x values that could give me the same y value. And the picture confirms that. This is a graph of radical x plus 9. It passes the horizontal line test. So if I want to find a formula for its inverse, my procedure for that is replace g of x with a y, swap the x's and the y's, and then solve for y. So I'm going to square both sides, and then subtract 9 from both sides. But I do have to remember that I'm going to restrict the domain here because x squared minus 9 looks like this, which is not a one-to-one function, right? So I'm going to restrict the domain so that it is a one-to-one function and so that its inverse is radical x plus 9. So the domain of this guy, the domain of g, actually I'm not concerned with the domain, the range of g is 0 to infinity. That should be the domain of f, right? That should be the domain of g inverse. So g inverse of x is x squared minus 9 with the added stipulation that x has to be bigger than or equal to 0. I'm restricting the domain so that it matches the range of the original function. All right, and then this last one, I have no formula, so the best I can do is to draw a graph. It does pass the horizontal line test, so it has an inverse. And when you sketch the graph of an inverse function, it is the reflection over the line y equals x. So I'll put that line in here. And to reflect over the line y equals x, you swap the x coordinates and the y coordinates. So I'll pick a few nice points on here. That's a nice one. Oh, that's a nice one. There's a nice one. That's good. All right, so this point right here is 5, 2. So to reflect over the line y equals x, I would plot the point 2, 5. And then this point is 4, 0, so I would plot 0, 4. And this point is 1, negative 2, so I'll plot negative 2, 1. This point over here is right on the line, so when I switch its x and y coordinates, it stays where it is. Negative 4, swap them, lands at negative 4, negative 4. So it looks like I'm going to have a graph that looks something like, oops, connect those better, that. The reflection of the original over the line y equals x.